Hi everyone, welcome to this lecture on clearing a very common confusion of reinforcement learning. So basically, when I first started to learn reinforcement learning, I came across a confusion which really messed up the rest of my learning because it was not cleared at the right time. I came to know that some of the other learners of reinforcement learning also had this confusion in their mind when they started. So I thought, why not clear it beforehand before we move into the crazy stuff? So the confusion is very, what I would say, a very cute confusion. So far you know all the basic elements of um, working in an RL based environment. You know that you are in a state S, you take an action A, and because you have taken this action A, you are going to receive a reward R. And also because you have taken an action into the environment, you are going to be in a new state which is S dash. Now you know that we were in a status, we took an action A, we got a reward from the environment for taking this action A, and we got into a new state which is S dash. But previously, I also told you about this policy, which is represented by pi, and I said that this action A is taken according to this policy. But if we are playing in the environment for the very first time, then from where does this policy comes? This is the question that wobbled my mind, that if we are playing in the environment for the very first time, then how do we already know the policy? The answer to this question is that we do not know the correct policy or any policy right now. We just randomly initialize a policy and we ask the agent to take actions in the environment with respect to this policy, which is randomly initialized. So the model takes action in the environment with respect to this randomly initialized policy, and it is going to reach new states and it is going to get rewards for them. So after playing for example 1000 samples, we are going to stop the agent and we are going to apply an RL algorithm on those 1000 samples so that we can improve our policy. So we started with an initially randomly initialized policy. We played in the environment using that randomly initialized policy, and after we have collected, for example, 1000 movements, 1000 observations, we are going to apply an RL algorithm on top of it to achieve a better policy. The RL algorithm is going to observe, it is going to work upon those 1000 sample, and it is going to improve our policy. So this new policy is pi dash. Now that we have an improved policy over the randomly initialized one, we are going to make the agent we are going to land the agent in the environment, and we are going to ask it to make new actions in the environment, but this time with respect to this new policy pi dash. So the agent is going to take action in the environment with respect to this improved policy pi dash. So for example, it is going to take 1000 new actions, but this time according to the improved policy. Then again, after it has taken, for example, about 1000 actions into the environment with respect to this improved policy, we are again going to stop the uh, agent and we are going to improve the policy using the RL algorithm, and it is now going to output a further improved policy which is pi double dash. Now that I am saying that we stop the agent, it is not always true. There are some nitty gritty details to it, but for now you do not need to care about them. So yeah, we initialized with a totally random policy. We played in the environment with the help of that randomly initialized policy, and we improved it using an RL algorithm. Then again we played in the environment, but this time with the improved policy, we played in the environment, for example, 1000 actions with the new improved policy, and then again we apply the RL algorithm on those samples which were produced by the new improved policy, and we are going to further improve the policy that we produced before. So By 2000 sample, we would have a policy pi double dash, which is the improved version of this one. Then again, we are going to put the agent into the environment, and this time the agent is going to take actions in accordance to this policy pi double dash. It is going to take 1000 actions into the environment according to this new policy pi double dash, and then we are going to apply a reinforcement learning algorithm on top of these collected samples, and eventually we will be able to improve the policy, and eventually we are going to get p triple dash. So we started with a randomly initialized policy, and we kept improving it after some passage of time, and eventually we are going to reach a policy pi optimal, which is the most optimal policy in this environment. So yeah, you should not be confused. We initialize this policy randomly. We keep improving it with the help of the actions, with the help of the observations that we have taken in the environment with respect to the policy. We improve over it, then we put it again, then we put the agent again into the environment. It acts upon according to the new improved policy. It again gather new information, it gathers new observations, and then again we use the RL algorithm to improve the policy, and the cycle continues until and unless we reach a policy which is optimal. How do we know that we have reached an optimal policy? You are going to understand it later on in the lectures. So yeah, this is the beauty of reinforcement learning. You start with a randomly initialized policy, and with the passage of time, with more and more observation, with more and more data, you are eventually able to reach the optimal policy, which depicts the most optimal action that you can take in any state. Now, I have repeatedly said that we do initialize a random policy, but there are some nitty-gritty details to it. We can be clever about how do we randomly initialize it. There are some nuances about it, but for now, you do not need to care about them. Just think that we randomly initialize this policy. I hope you won't be bothered about this confusion later on in your lectures. I've tried to clear it beforehand, and I hope you understand what I told. See you in the next lecture.